Suppose we wanted to evaluate this integral, and suppose we wanted to do it by our method of direct substitution. First of all, you're going to have to go through these steps, which can look quite daunting, but as you practice more and more, the steps will start to flow better from one to the other, and it'll become second nature to you, but it does require lots of practice. Before we actually get started with this, let's copy the problem back down again. Now let's just go through the steps. Step 1 says to set u equal to the expression raised to the power. Here that would obviously be the x minus 6. So we set u equal to x minus 6. Step 2 says to compute du dx. That's the derivative of u with respect to x. That would just be 1. Step 3 says solve for x. So we're going to multiply both sides by dx. On the left, the dx is divide out, and you're left with du equal dx. Technically, we're solving for dx, so if you want to, you can write that dx equals du. Step 4 says if the integrand has a numeric constant factor, move it outside the integral. That's a number that's being multiplied by everything in the integrand. There's not one of those here, so that doesn't even apply. Step 5 says to substitute both the u and the expression represented by dx into the integrand. And notice that this step will remove every trace of the x and the dx, for that matter, from the integrand, if you've done it properly. So we go back here and we look at this. We know that u is equal to x minus 6, so we actually go in and physically remove the x minus 6 and replace it with u. And we do the same. Dx is equal to du, so we replace the dx with the du. Notice that when we're done, we have no x's or dx's, we have only u's and du's. Step 6 says to simplify the integrand, but that's about as simple as you'll ever see an integrand, so there's really not anything to do here. Step 7 says to use the general power rule for integration. The general power rule, remember, says that you can integrate u to a power by increasing the power by 1, going from n to n plus 1. And here, you'd be adding 1 to 3 halves. And just remember, I don't want to spend much time doing arithmetic, but adding 1 to a fraction, in particular 3 halves, is like adding 2 halves to 3 halves. That gives you 5 halves. So the new power will be u to the 5 halves, and then you have to multiply by the reciprocal. 1 over something is the reciprocal of it. The reciprocal of 5 halves is 2/5. And as always, with an indefinite integral, you have to add plus c. Step 8 says to substitute the x values back in and simplify the result if necessary. Here, the x minus 6 was what u was. We put the u in there. It was not there in the beginning, so getting rid of it, the x minus 6 goes back in instead of the u. And let's just write it at the top. And keep in mind, if you have any doubt that you got the answer right, all you have to do is take the derivative of what I've just boxed in there and convince yourself when you take its derivative, you get what you started with. You can always check these integrals by differentiating and see if you get what you started with. So if you end up with that answer, differentiate it and see if you get back the integrand that you started with. If you do, you know you got your integral right. In any case, there's your answer.